This is problems 33 through 38 on the AB Fall Review multiple choice packet. If C is a number defined by Rolle's theorem, then for f of x equals 2x cubed minus 6x on the interval, on the closed interval 0, root 3, C is. So we're trying to find the C value for Rolle's theorem. Let's just go through the conditions for Rolle's theorem. Okay. We have a polynomial, so we know that it's going to be a smooth curve everywhere. There's no sharp points. There's no discontinuity. So the first condition for Rolle's theorem, function is continuous on the closed interval. That's true. The function is differentiable on the open interval. This is also true since we're dealing with a polynomial. And now the third condition we need to test is, do the endpoints produce the same y value? So we can plug 0 into the function. So we plug 0 in for x. We get 2 times 0 cubed minus 0. So that's 0 minus 0 is 0. And we know that's we have the order pair 0, 0. If we plug in root 3, 2 times root 3 cubed would be 18 root 3 minus 6 root 3. So, I'm sorry, 2 times root 3 cubed would be 6 root 3. So 6 root 3 minus 6 root 3 is also 0. So the endpoints do produce the same y value. So all three conditions have been met by Rolle's theorem. And Rolle's theorem tells us then that we can guarantee a place where the slope on the curve is equal to 0. So we set f prime equal to 0, and then we solve for x. So we're looking for the location. Okay, the c value is basically this x value. Looking for the location on the curve where the slope is 0. So we find f prime, which is 6x squared minus 6. We set the derivative function equal to the slope that we're targeting, and then we solve for x. When we solve for x, we're looking for the location where this specific slope will occur. So I can factor out a 6, difference of squares, solve for x. I get x equals 1 and negative 1. However, the location that we're looking for has to be on the open interval between 0 and root 3. So negative 1 is outside the interval, so we have to eliminate that. The only c value or only x value that we have that's between 0 and root 3 is going to be 1. So c is equal to 1 on the open interval from 0 to root 3. 34, the slope of the curve y cubed minus xy squared is equal to 4 at the point where y is equal to 2 is. So we're trying to find the slope of this curve, so we have to go through the derivative. But notice that the y variable is mixed into the equation, so we have to go through the derivative using implicit differentiation. And also product rule, because x and y squared are two separate variables related to one another by multiplication. So we have to go through product rule. And if we want to find the slope, okay, so let's go through the derivative steps. Okay, we're going to find dy dx, and then we're going to plug in the order pair to find the particular slope value. So let's go through the derivative process here. So y cubed becomes 3y squared, okay, dy dx. Okay, I need to include the dy dx after 3y squared. Minus, now I have to go through product rule, so f prime g plus fg prime, so x becomes 1, y squared stays, plus f g prime, so x stays, and then the derivative for y squared will be 2y dy dx equals 0. Okay. And if I distribute the negative through, I'll get 3y squared dy dx minus y squared minus 2xy dy dx. And now it's just a matter of trying to rearrange and try to get the dy dx together, and then we can factor this out. So, but I think actually we don't have to necessarily do that because we're just looking for the slope. So we can just go ahead and plug in the order pair into this derivative equation and then just solve for dy dx. We'll make things go a little faster. However, if you look at this derivative equation, we're going to need both the x and the y value. We're only given the y value, so we have to find the x value. So the way we find the x value is we plug y, this 2 into the original equation and try to find what the x value is. So we plug in 2 in for y. So y cubed becomes 2 cubed minus x 2 squared equals 4. So 8 minus 4x equals 4. We solve for x equals 1. So the order pair is going to be 1, 2. We have our order pair. We're going to plug into our derivative equation. So 1 plugs in for x, 2 plugs in for y. So we get 3 times 2 squared dy dx minus 2 squared minus 2 times 1 times 2 dy dx. And then we just try to clean this up, right? So 3 times 2 squared is 12 minus 4 dy dx. Combined like terms, we get 12 dy dx minus 4 dy dx is 8. Dy dx minus 4 equals 0. We solve for dy dx, which is equal to 4 over 8. And 4 over 8 is 1/2. So that is the value of our slope. Okay, 35. The equation of the line tangent to the curve. So if we want to find tangent line equation, we need the order pair, which we have, and we need the slope, which have to come from the derivative. And if you look at the way that this is set up, we have to go through the derivative procedure, applying the product rule. So product rule f prime g plus f g prime. So x's derivative becomes 1, f prime times g plus f g prime. The derivative for sine is cosine. And once we have the derivative, we can evaluate the derivative by plugging in our x value into the derivative. So all the x's gets replaced with pi over 2. So sine of pi over 2 plus pi over 2 cosine of pi over 2. Sine of pi over 2 is 1. Pi over 2 times cosine of pi over 2. Cosine of pi over 2 is 0. So 1 plus 0 is 1. We have our slope, which is 1. We have our order pair. And now we can just plug into point slope. So y minus pi over 2 is equal to 1 times x minus pi over 2. The answer choices are simplified a little further. So if I distribute the 1 through, I get x minus pi over 2. If I add pi over 2 to the other side, they cancel out. So the simplified equation is y equals x. 36. The minimum value of the slope of the curve is, for this equation, for this curve is, so minimum value of the slope. So think of it this way. The minimum value of the slope is basically the POI where the concavity changes from concave down to concave up. So we're basically looking for the location on the curve where the steepness is at its most negative. Okay, its steepness is at its most negative. And in other words, that's going to occur. Okay, so if you were to look at a graph, right, the maximum or the minimum steepness is going to occur at a POI where so this is the most negative that the slope is going to get on this curve, and this is also the POI, point of inflection, where the concavity changes from concave down to concave up. So we're essentially looking for this point right here. We're looking for this POI, and if we want to look for this POI, we would have to find the second derivative and then consider whether the concavity changes from down to up. So to get to the second derivative, we have to go through power rule twice. So 5x to the 4th plus 3x squared minus 2. Find the second derivative, 20x cubed plus 6x. And then to find our critical value, we set our second derivative function equal to 0. I'm going to factor the 2x out and then set both portions equal to 0. If I set 2x equal to 0, I get 0. If I set 10x squared plus 3 equal to 0, I get an imaginary number. So the only real number that we have is 0. So I use 0 on the number line. If I plug -1 into the second derivative, this is always positive. So 2 times -1 is negative, so concave down. If I put in +1, I get positive times positive, which is positive. So concave down to concave up, it's exactly what we want to find that minimum slope steepness. So so it says the minimum value of the slope, which means that we're trying to look for what the slope is. So we need to plug 0 into the derivative function because we want to find out the actual steepness at this point. So if we plug 0 into the derivative, I get 5 times 0 to the fourth plus 3 times 0 squared minus 2. 0 plus 0 minus 2. So the minimum steepness on this curve is going to be slope of negative 2. 37. The equation of the line tangent to the hyperbola at the point 42 is, so if we want to find the tangent line equation, we need to find the derivative. And in this case, notice that the equation is set up in a way where we have to go through implicit differentiation. So x squared becomes 2x, y squared becomes 2y, attach dy dx equals 0. And then we just have to solve for dy dx. So subtract 2x, divide by negative 2y, we get x over y. Now, looks like the derivative equation requires both the x and y value, so we're going to plug 4 and 2 into the derivative function, or the derivative expression, and we get 2 gets replaced with 4, y gets replaced with 2, so 4 over 2 is 2. We have our slope, we have our ordered pair, and now we can write our tangent line equation. So y minus 2 is equal to the slope 2 times x minus 4. And the answer choice is requiring us to simplify a little further, so distribute the 2 through, so 2x minus 8. Add 2 to both sides of the equation, y equals 2x minus 6. Answer choice C. 38. The line tangent to the curve is vertical when, so if we want to find out where the tangent line is vertical, this is basically where slope is undefined. Okay, so if we want to find out where the slope is undefined, we need to set the denominator of the derivative equal to 0. Okay, so before we can do that, we need to first find the derivative. And notice we have y's in the equation, mixed into the equation, so we have to go through implicit. And again, x times y, so we have to go through product rule. Okay, so let's go through the steps together here. Y squared becomes 2y dy dx. Go through product rule. So f prime g plus f g prime, the derivative for y, turns into dy dx. Plus 9 equals 0. 9 goes to 0. 9's derivative is 0. And 0 stays 0. So now I'm just going to try and solve for dy dx. Distribute the negative 1 through. I get 2y dy dx minus y minus x dy dx equals 0. Group the dy dx terms together on the left side. Move the negative y to the right side. Factor out the dy dx. And I'm going to now divide both sides by 2y minus x. So now I'm looking for a location where my slope is undefined. Okay, vertical tangent line. So I'm going to set the denominator equal to 0. 2y minus x equals 0. 2y minus x equals 0, which is x equals 2y. Now, we're not getting a real number out of this, so we have to go through another set of substitution. We have to take this information, plug it into the original equation, and see if we can find out one of the either value for x or y. So it looks like maybe easier to replace the x, because that way we don't have to deal with a fraction. So I'm going to replace x with 2y. When I do that, I get y squared minus x gets replaced with 2y, so 2y times y plus 9 equals 0. So y squared minus 2y squared plus 9 equals 0. Y squared minus 2y squared is negative y squared. Negative y squared equals negative 9. Divide both sides by negative 1. Take the square root. I get y equals plus or minus 3. And that is our answer choice.